Hi, welcome to Technical and Engineering Academy. This is Blessed Elvis. Okay, so to use the inverse rule for us to find the unknown values of the given simultaneous equation, it's very wise that we understand how we express this. So we know that the inverse of a matrix, let's say in this case A, is always 1 over the given determinant. Okay, before I do this, let's say we have an example of a matrix, let's say A, B, C, and D here. So for us to, let's say this is our matrix A. For us to determine the inverse of this matrix, I know we are looking for the simultaneous equation inverse rule, but for us to answer that kind of simultaneous equation, we first have to express it into a what? A matrix form. So it's very much wise that we have a background of the matrix format, or rather the matrices in general. So for us to find the inverse of this matrix, we know we have to find 1 over determinant, and then here you exchange these values, meaning the D comes here and then the value for A comes there, and then these guys will have the negatives. So introduce the negatives. So if they were negatives, they would have been positives. So this is how we find the inverse. So you find the determinant, you put it here, and then you write the opposite of these values, and then you exchange these values here with the negatives. So let me give an example. Let's say you have 2, 3, 4, and 5 here. How can you find the inverse of this? So to find the inverse of this, let's say this is our matrix B. To find the inverse of this, we first have to find the determinant, or rather, if we don't want to waste much time, we just have to say inverse in this case is gonna be 1 over determinant of what? Of the opposite of this, that is 3 and 2 here, and then the negative signs of these, that is negative 4 and negative 5. So in this case, let me just also, where there is determinant here, let me just find the value for the determinant. So we have, to find the values of the determinant, you multiply the major diagonal, that is 2 multiplied by 3, which of course is 6, and then you subtract the minor diagonal, which is 5 multiplied by 4, which of course is 20 here. So let me find the value for that. So it's 1 over, so in this case, 6 subtract 20, we are going to have what? Negative 14. Okay, let me just write that. Negative 14 here. So here you have 3, negative 5, negative 4, and 2. So this is the general concept that is behind. You also multiply this throughout in here. So that is the inverse. Now that we have understood this, let's go now direct into answering questions for simultaneous equation using inverse rule. So let's say you have an example of a simultaneous equation. We have x 2y equals to 4 rather here, and then here you have 3x minus 5y equals to 1. So the first thing is expressing this in matrix form. So this is the same as 1, 3, 2, negative 5. Rather, this is 5, negative 5. And then here you write, so since we are beginning with x, so it's going to be x, y, equal to whatever answers we have, that is 4 and 1. So in this case, you have to find the inverse of that. So the inverse of this, you multiply with this. Then that's your answers for the x and y. So let's do that. So in this case then, let's say this is, okay, this is our matrix, right? So it's going to be 1 over the determinant of this. So determinant of this, we know it's 1 multiplied by negative 5, which is negative 5, minus here 3 multiplied by 2, which is 6. And then here, you are going to write the opposite of negative 5 and 1. So negative 5 will come here, and then 1 will be there. And then this, we are going to write the negative signs. So negative signs of 3 and 2, we are going to have negative 3 here. And also we are going to have, here we are going to have what? Here we are going to have negative 2. So we have that. And then here, you multiply with 4 and 1. So these will be your values of what? X and Y. So don't be confused. We are going to look at another example so that you get a clear picture of whatever I have done here. If you are confused, I have said you simply multiply the inverse of the matrix given with the answer that you have on the equal sign. That's what I've done. So I'm just finding the inverse of this. Okay, so in this case then it's 1 over negative 5 and negative 6. There it's negative 11. So here we have negative 5, negative 3, negative 2, 1, and then here we have, okay, let me write this, okay, and then here we have 4, 1. Okay, so equal to values of what? X and Y. Okay, so let me just wrap this part here that we have. Okay, so in this case then we are going to have 1 over, if you want you can write the negative there, it does not matter. So in this case, let's multiply this with that. So let's find the values of these first. So in this case, it's going to be a product. So you multiply with the row by this column here. So we are going to begin with negative 5 multiplied by 4. It's what? Negative 20. And then you add here. So you add negative 2 multiplied by 1, which is of course negative 2. So it's going to be negative 2 here. You come down there with this row again. So whatever you did here with that, you also do here with this. So in this case, it's going to be negative 3 multiplied by 4 here. It's going to be negative 12. And then 1 multiplied by 1, it's what? It's 1 here. So we have that. Go to the values of X and Y. So in this case, then, it's going to be negative 1 over 11 here. Let's simplify this. So what is negative 20? We subtract 2, we are going to have negative 22. And then negative 12 plus 1 is negative 11. Okay, so this is going to be equal to xy because those are the values that we are finding. So let me just wrap the top part here so that we find, or rather we have more space. Okay, so in this case, let's multiply this with whatever we have there. So in this case, it's going to be negative 1 over 11 multiplied by what? Negative 22. So this is the value of x. And then negative 1 over 11 multiplied by whatever we have down there, that is negative 11. This will be the value for y. So let's find the values for that. So hopefully you can manipulate these calculations. So negative and negative, it's what? Positive. So 1 multiplied by 22, it's 22. Remember we have over 11 equal to the value of x. So again, negative and negative, it's positive. Then 1 multiplied by 11, it's 11 over what we have here, 11 equal to y. Okay, let me wrap the top part here now, since it's not of use. So in this case then, we are going to have 11 divided into 22, it's what? It's 2. So in this case, x is 2. 11 divided 11 is 1, so y is 1. So in this case then, x equal to 2 and y equal to what? 1. So this is the answer. So let's look at another example so that we understand more. So let's say you have 3x plus 4y equal to negative 14. And then down there we have negative 2x minus 3y equal to 11. So in this case, we have to write it in standard form of the matrix. Of course, we know it's 4 and negative 3 there. Okay, here we are going to have x and y, since these are the values we are looking for here. By the way, there can be any variables present in the expression. It's not always x and y. So after we are done with this, you find the inverse of this. So we know by now it's 1 over the determinant. So determinant is 3 multiplied by negative 3, it's negative 9. Then minus here, negative 2 multiplied by 4, it's negative 8. Okay, then here you write the opposite of this. So this negative 3 will come here, and then this 3 will come where? Will come here. Okay, let me just write it properly. We will come here. and then here we write the opposite sign. So here we have negative 2, so it's going to be positive 2. And then here you have positive 4, it's going to be negative 4. Okay, and then here we are finding the values of what? So here you multiply you multiply with whatever you have here. Okay, so that is multiplication of negative 14 and 11 there. So we are finding the values of what? X and Y. Okay, so let me wrap the top part here. Hopefully you have understood the concept here on how I am expressing the given simultaneous equation in such a manner. So when you understand this, it's going to be simple for you. So we have negative 9, negative and negative there, it's positive, so negative 9, positive 8 is what? It's negative 1. So here we have, okay, we have negative 3, we have 2, have negative 4, and we have 3 there. Okay, we are multiplying this with the matrix negative 14 and 11. All of these equated to X and Y. So in this case, negative 1 into 1 is negative 1 there. So let's use the multiplication form of the matrices here. So this is the row, we multiply with the column here. So in this case, we're going to have negative 3 multiplied by negative 14. So negative 3 multiplied by negative 14, it's what? Okay, so negative 14 multiplied by negative 3, it's positive 42, because negative and negative, it's positive. So it's positive 42. Then plus negative 4 here multiplied by 11 here, we are going to have what? Negative 44. So here we initially add, but positive multiplied by negative, it's negative. So 4 multiplied by 11 here, we are going to have 44. And then down there, we do likewise, row by column. So in this case, it's going to be 2 multiplied by negative 14. Of course, we know it's what? Negative 28. And then we add here 3 multiplied by 11 is negative, or rather positive 33. So all these are equated to X, Y. So let me just wrap this, whatever we have here. So hopefully you have followed up. So make sure for the calculations, make sure you are with a calculator so that you follow up whatever I'm doing here. So we have negative 1. Okay, we have negative 1. So what is 42 subtract 44? We have negative 2, right? Okay, and then negative 28. Negative 28, we subtract 4. We subtract 33, it's what? Okay, it's positive 5. So it's 5 here. Okay, and then equal to X, Y. So what is this multiplied by that? Of course, it's positive 2. And then negative multiplied by positive 5, we're going to have negative 5. So this is going to be X, Y. So these are our values. So we have X, Y equal to what? 2 and negative 5. So these are our values. So X equals to 2 and also Y equals to negative 5. So these are our values. So this is how we find the answers of the unknown values of the given simultaneous equation using the inverse rule. Thanks once again, guys, for staying this far. Please like, subscribe, share, and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.